Hi, so we are going to be doing lesson 9.2, which is on page 128 in your consumable. 9.2 is really just looking at a different way of expressing slope in the way that we see it normally in word problems, which is the rate of change. So let's do screen. So the rate of change for a function is the ratio of the change in y, which is the dependent variable, to the change of x, which is the independent variable. Whoa, that sounds a little familiar. The change in y to the change in x, change of y to the change of x, rate of change is just my slope. It's how much am I changing by. So today in this lesson, we're going to be able to calculate and interpret the rate of change for a function. Then we're going to be able to understand the connection between rate of change and slope. So that's how we're changing. So looking at this situation, it says Margot went to the lumberyard to buy supplies to build the wheelchair ramp. She knows that she will need several pieces of wood, each piece costing $3. So A says write a function f of x for the total cost of woods if Margot buys x number of pieces. Well, so f of x, so function f with inputs x, is going to equal $3 for each piece of wood. So that would be 3 times x, where x is my number, my x pieces of wood. So then it says make an input-output table of ordered pairs, then graph the function. So our graph is going by 2, so we'll do 0, 2, 4, 6, 8, 10. Then the total cost, so if she bought 3 pieces of wood, that would be 3 times 0, which is 0. She bought 2 pieces of wood, that'd be 3 times 2, which is 6. 4 pieces of wood, that'd be 3 times 4, which is 12. So then that would be 18, and then 24, and then this one would be 30. So let's graph that. So 0.00, and we're going to run out of room on our graph. Then we have 2, 6. Then we have 4, 12. Then we have 6, 18. And then, we're running out of room to graph 8 and 10. But look at that. It's forming a straight line, so it is linear. So it says, what is the slope of the line that we graphed? Well, we go up 6 over 2. So change of y equals 6 over change of x, which is 2. So 6 divided by 2 is 3. So the slope of the line is 3. And then it says, by how much does the cost increase for each additional piece of wood purchased? Well, $3. My rate of change. So then it says, how does the slope of the line relate to the situation with the pieces of wood? So the slope is my rate of change. So it says, is there a relationship between the slope of the line and the equation of the line? Yes. The slope is my coefficient. Remember, coefficient is when a number multiplies with a variable. So y equals 3 times x. That's my coefficient. So we have Margot doing a different story. So Margot is going to work with a local carpenter during the summer. Each week she'll earn $10 plus $2 per hour. Write a function f of x for Margot's total earnings if she works x number of hours in 1 week. Well, f of x, function f in terms of x, meaning x is the number of hours, is going to equal the $10 that she works plus 2 times any additional hour that she works. She's getting $2 per hour. So per is a good multiplication word. So 2 times x. So it says make an input-output table of ordered pairs, then graph the function. It's going by 2s again, so let's go by 2s. So you have 0, 2, 4, 6, 8, 10, 12. If she works 0 hours, well, she's still getting that $10. If she works 2 hours, she gets 2 times 2, which is 4, plus 10, so 14. And then it's actually going to keep going up by 4. So 18, 22, 26, 30. Whoa, that was weird. 30, and then 34. Let's graph it. So 0, she's now at $10. 2, she's at 14. 4, she's at 18. Hoping we're running out of room with this one too. But notice it is straight line, so it is linear. So it says, how much will Margot's earnings change if she works 6 hours instead of 2? Well, if she works 6 hours instead of 2, she makes $8 more. So $8 more. And then if she works 4 hours instead of 3, so 3 would be 16, so she gets $2 more for that second situation. So it says, how much do Margot's earnings change for each initial hour worked? Well, that's $2 per hour. So does the function have a constant rate of change? Yes. It's 2. 2 per hour. So what is the slope of the line we graphed? Well, if we go back, we go up 4 and then over 2. So change of y is 4. Change of x is 2. So that would be a slope of 2. So the slope of the line that we graphed is 2. And then it says, describe the meaning of the slope within the context of Margot's job. So $2 per hour that she works. Oops, jab. So then it says, describe the relationship between the slope of the line, the rate of change, and the equation of the line. Well, my slope is my rate of change. So they're synonyms. Rate of change. Just getting good handwriting right now. So how much will Margot earn if she works 8 hours in 1 week? Well, we found that. She's going to earn $26. So it says, by the end of summer, Margot has saved $375. Recall that each of the small piece of wood costs $3. So it says, write a function, f of x, for the amount of money that Margot will still have left if she buys x number pieces of wood. So we have f of x. Well, she starts off with $375, and then we're taking away $3 per piece of wood, so it'd be minus 3x. And it's loading. Hold on, let me refresh my page. Joining us for our commercial break, the loading screen. Yeah, I was trying to make this video fast and made me reload. There we go, come on. Oops, pop it up, there we go. So then it says, make a input-output table for the ordered pairs, then graph the function. So, oops, my goodness. Oh, what? Okay. So make an input-output table for the ordered pairs. So pieces of wood, so it's going by 50, so let's go by 50. So 0 pieces of wood, 50 pieces of wood, 100, 150, 200, 250. So if she buys 0 pieces of wood, she still has her $375 left. If she buys 50 pieces of wood, that's going to mean it's going to be $150. So 375 minus 150 would be 225. And then it's actually going to go down by $150 each time. So then that would be $75. Oh, and then she has no more money. Hold on one second. All right, so we start up at the 375, and then it's going to keep going down. So 50, 225, right there, 175. Oops, where are we? There's 100. And then it's just going to keep going down like that until she runs out of money. So it says, how much will the amount Margot have saved change if she buys 100 of pieces of wood instead of 25? Well, if she buys 100 pieces of wood, that's 70. And then if she buys 25, that's 300. So that would be, she would save 225. Or how much she will have saved will change by $225. And then if she buys 50 instead of 0, well, if she bought 50, that would mean she'd have 225 left. And then if she bought 0, so that's a change of $150. And then for each additional piece of wood, each piece of wood changes by $3. So does the function have a constant rate of change? Yes. It's the $3 per piece of wood. And then it says, what's the slope of the line that we graphed? Well, we go 375 to 325, so that's 150. 150 for 50 pieces of wood. So that would be 3. So the slope is 3. How are the rate of change of the function and the slope rate? They are the same. Describe the meaning of the slope within the context of Margot's saving. So it's $3. Oops. Per piece of wood she buys. That's how it affects her savings. So how does the slope differ from the other slopes that we have seen in this activity? Well, I guess since it's going down, it's actually going to be -3, and this one would be -3 because we're going down 150. So my slope is -3. So the slope is negative. This slope is negative because we're going down. All right, and then your lesson practice is the 9.2. If you have questions, let me know. Come to my office hours. See you there.